Okay guys, this is going to be part 2 of our video on simplifying rational exponents, the day 2 worksheet. I've already done problems 3, 4, 5, and 6 on part 1 video, and so now I'm going to finish up this worksheet for you guys. So before we start on number 7, let's go look at number 8. So we have x raised to the negative 1/3. So we know because we have this negative that we need to move it to the denominator so that we can get rid of that negative exponent. So to do that, we would get 1. Ooh, too big. Okay, let's try that out again. We get 1 over x to the 1/3. So now we've got a fraction in our denominator, which we're not allowed to have. So we need to think, we kind of talked about this, didn't we talk about this a little bit in problem number 4, where we're kind of looking for a whole fraction. So if we were to look at this one, we have 1x where we need 3 x's. So to do that, we need to think to ourselves, okay, in the end, I need this to be x to the 3/3, so therefore, this can just be x. So we have to think, what do I need to multiply this fraction, this right here, what do I need to multiply this by to get me to this x raised to the 3/3? Well, remember when we're multiplying exponents, we typically, we're able to, if they have the same bases, add our exponents together. So think to yourself, okay, so if I'm doing this, what do I need this x to be able to get x to the 3/3? Because this means that we can add these together. So hopefully in your head you know that to have a common denominator, so it needs to be a 3, and to get 1 plus what will give us 3? Well, that would be 2. So we need to multiply this by x to the 2/3. When we do the denominator, we must also do to the numerator. So we get, on the top, on the numerator, we get 1 times x to the 2/3, which is just going to be x to the 2/3. And in the denominator, we already know what we're getting. We're trying to get x to the 3/3, which we did because 1/3 plus 2/3 give us 3/3. And x to the 3/3 is going to simplify down to be x to the 1st, which is just x. So now let's take this, your numerator, and let's put it back in radical form. Because we're allowed to have radicals in the numerator, we're just not allowed to have them in the denominator. It's not completely simplified. So to do this, we know that our index is going to be 3, or our root is going to be 3, and then our base is x, and its exponent is going to be 2. And then there's nothing else that we can do on this one, so we are done. Can't simplify any further. So good job on that one. So now let's move to number 7. Let's look at that. So this takes what we did in number 8, but this one's just a little bit more complicated. So let's work through this. First, let's go ahead and deal with this negative exponent right there. So we want to get rid of that negative. To do that, we're going to move y to the numerator. So therefore, we're going to have x to the y to the 1, x times y to the 1/2 times y squared, all over x to the 3/4. So at this point, why don't we simplify the y's? So again, if we're being multiplied, the same base being multiplied together, we can add the exponents together. But to do that, we need a common denominator because this is, excuse me, over 1. So we would get x to the 1/2, y to the 1/2. So it's x times y to the 1/2 times y. Well, we need it to be a denominator of 2. So then we multiply the top, the numerator, and the denominator by 2. So we get 2 times 2 is 4. So we get 4 halves all over. And we'll save this x to the 3/4 for later. We'll deal with that in just a minute. So now we can add these together because we have common denominators. So we get x times y to the 5 halves all over x to the 3/4. So we have an x in the denominator, and it's got a fractional exponent, which we're not allowed to have. But we also have an x in the numerator. So if we wanted to, we could take, because these are the same bases, I'm going to tickle on my throat, I'm sorry. We can take this and we can subtract the exponents. So if I need my numerator to have a common denominator, I would want it to be fourths because my denominator has to the fourths. So this could be, as a whole, for it to be 1, could be 4/4. And then the denominator would be x to the 3/4. So now we can just subtract these. So we have x to the 4/4 minus 3/4. And don't forget your y to the 5 halves. So what's 4/4 minus 3/4? Or we would get x, right, to the first and y to the 5 halves. If we wanted to write this as a fractional exponent, we would write this, as a radical. This would be x square root, because the index is 2, and there's an understood 2 here. We don't have to write that. And we would have y to the 5. Now, what did we not do that we should have done? Let me erase this because we did not simplify. I did not simplify. So we need to simplify this because we can. Because we have 5 y's under a square root. Well, that means we can pull out some of those y's. And if we wanted to write this as a mixed number, we could write it as y to the, how many times will 2 go into 5? Well, we'll go in there 2 times with 1/2 left over. So we get the x to the first. Well, this whole number 2 means that there are 2 pairs of y's that we have taken out of our square root. So if we were to write this in radical form, it'd be x y squared. And what's left under your radical? Well, just 1y. And then we're done. Okay, let's flip over to the second page. And let's work through these. I will probably have to do another video, so let's do about 4 more, see where we go, and I might have to do another video tomorrow in the morning. Let's look at this other one. So here we have a fraction raised to a negative exponent. Well, when we talked about this in previous lessons, we've talked about how we could take the reciprocal of this and then it changes this to a positive 1/3. So if we do that, we would get 8 over x to the 6, y to the negative 9, and we'll deal with that negative 9 in just a minute, all raised to the positive 1/3. And if you have any questions about this, you can come ask me and we'll talk more about it and I'll show you an example of why this works. So now let's move our negative 9, our y to the negative 9, to our numerator. So we would get y, or 8, over x to the 6, and our y is now going to be in our numerator. all raised to the 1/3. It didn't show up. So now we need to distribute this 1/3, exponent of 1/3, to all of our terms. So when we do that, I'm going to come back up here. So we get 8 to the 1/3. Why? Well, what happens when we're raising an exponent to another power? Well, we multiply them together. So you have 9 times 1/3 is going to give you 9/3. And we'll simplify that in just a minute. Over x, and 6 times 1/3 would give you 6/3. So let's simplify those. And if we do this, this 9/3 becomes just a 3. And this x to the 6/3 just becomes a 2. So that becomes that. So then we have 8/3. Well, how could we maybe rewrite this 8 for it to be a smaller base? Well, you could rewrite it as 2 to the 3rd raised to the 1/3. And then you're going to have your y to the 3rd all over x squared. So now, when you're raising a power to another power, you multiply those together. And if you do that, 3 times 1/3 ends up canceling out, and it just becomes 1. So our final answer is going to be 2y to the 3rd over x squared. And then we're done. Okay, number 10. Let's look at that one. So we have a power raised to another power. This one might look a little ugly, and if you wanted to, you could go ahead and deal with the negatives, but what happens is when we multiply these exponents together, they ended up, a negative times a negative is going to give us a positive. So maybe if we just go ahead and multiply them together, you might find that that would be the easiest way to go. So if we have x and negative 3/8 times negative 4/9, you could cross simplify here. So you could take the 3 and the 9 and simplify that way. Or you could say negative 3 times negative 4 is going to give me a positive 12 over 72. And if I simplify that, what am I going to get? Well, I'm going to get x to the 3rd. And let's make sure that that works out. I don't see this on my sheet. So if I were to cancel it like this, you'd be left with 3. This would be 1. This would be 2. And it would be to the 6th. Not 3. So we have 1/6. So if I wanted to rewrite that as a radical, I would say the 6th root of x. Hopefully that makes sense to everybody. If not, please come see me before after school and I can clarify. All right, let's do number 11. So on this one, I would go back to rewriting this as a smaller base. So how can we rewrite 64? Hoping that maybe we can cancel something out with that denominator of 6. Well, if you recall, 2 to the 6th is 64. So we can rewrite that as 2 to the 6th, but it's still being raised to this 5/6. So if we multiply these together, that's 6 over 1 times 5/6. These cancel out, and then you're left with 2 to the 5th. And 2 to the 5th, I believe, is equal to 32. That one was pretty easy. So let's move on to number 12. So here we go. Here's our problem. We have a fraction, a fractional exponent in our denominator, which we're not allowed to have. So we have to think to ourselves, what do I need to multiply my denominator to get in the end? We need this to be, because this is a denominator of 3, we need this to be 7 3/3, because 7 raised to 3/3 is just 7 to the first. And that's what we need. So we get rid of our fractional exponents. Well, because you have 2/3, so 2/3 plus what is going to give us 3/3? Well, hopefully everybody would tell me 1/3 plus 2/3 is going to give me 3/3. So I need to multiply my denominator by 7 to the 1/3. What we do to 1, what we do to the denominator, we must also do to the numerator. So on the top, because these are not the same bases, we are not allowed to add our exponents together. So this is just 14 times 7 to raise to the 1/3. And in the denominator, we've already done this. We know that 2/3 plus 1/3 is going to give us 3/3, which is going to give us 7 to the first. Now let's deal with what's in our numerator. So we have 14, but what would this be? What would a 7 1/3 be if we had to write it as a radical? Well, at this point, you would tell me it would be a cube root of 7 to the first. Are we allowed to simplify here? Well, hopefully you would tell me no. The reason is they're not the same radical. This 7 is a whole 7, where this 7 in the numerator is just under the radical of 3. So a cube root. So we're not allowed to do that. But what we can simplify is this 14 divided by 7, which gives us 2 cube root of 7. And then that's all for that one. Maybe we could do these last couple. Let's look. Let's do 13. So on this one, what I would suggest is splitting these up. So you would have the cube root of 64 over the cube root of 27. And so then I would do, remember, this was algebra 1 and algebra 2. We want to do them as fractional exponents. So we can change this into 64 to the 1/3 and then over 27 to the 1/3. So at this point, I hope you can see that we need to change these both to smaller bases so that we can see if we can cancel something out. So I know that 64 could be rewritten as 2 to the 3rd raised to the 1/3, and 27 could be written as 3 to the 3rd raised to the 1/3. And at this point, these 3's would cancel, so then we're left with 2 to the 1st over 3 to the 1st, which is just 2/3. And then we're done. Okay, number 14, let's look at that. Problem here is that we have this negative exponent. So we need to change that to 1 over y to the 3/4. Well, here comes our problem again, where we have a fraction and our denominator. So we need to multiply this by, if I have 3/4, and in the end I need this to be 4/4, then I know that I need to multiply it by 1/4. So y to the 1/4 to the numerator and to the denominator. So in our numerator we have y to the 1/4, and in our denominator we have 3/4. 3/4 plus 1/4 is going to give us 4/4, which is just going to be y. And if we change this to a radical, this would be the 4th root of y. And then we've simplified. Okay, let's see. what 15 looks like. So again, I would change this to a improper fraction. So you get 81 to the 1/6. And I would change this base to a smaller base. So it would be 3 to the 6 raised to the 1/6. I'm hoping now that you're getting the hang of this and it's becoming much easier for you. And so these would cancel, and so then we're left 3 to the 1st, which is just 3. That was not bad at all. Okay, last one. So the first thing that I would do here, and hopefully you will see this, is that I would simplify my numerator because I've got two of the same bases, so I can add these exponents together. And look, they happen to be the same denominator. So if I add these together, I get 4/3 plus 2/3 is going to give me 6/3 over 1/3. And so now I know that 6/3 is going to be 2. So if I keep simplifying this, I'm going to have x squared. But hold up. At this point, I'm not sure if that's going to be the best bet for us. Uh-oh. Oh, I do not want to do that. I switched. Let's see if I can find it again in my stuff. Sorry, guys. I am not seeing it. Was this it? Oh, here it is. But is this what I'm looking for? Sorry, no, this one's not it. Uh-oh. Of course, at the very end, I must have exited out of this. Okay, so what I'm going to do is I am going to add a page below this. Let's just do plain paper. And let me find this problem again. And here it is. Okay, so I'll just redo it over here. So it's x to the 4/3 times x to the 2/3 over x to the 1/3. So we said on the numerator we would get x to the 6/3 over x to the 1/3. And hopefully you would see that this is the same denominator, and because we have the same base, now we can subtract those exponents. So that's why we don't want to go ahead and simplify them, because then we're going to be doing more work and we'd have to do this again anyway. So you get x to the 6/3 minus 1/3, and this is going to give us x to the 5/3. And remember, because this is an improper fraction, then we can simplify this. A way that you can do this is you can say, how many times does 3 go into 5? Because that's how many groups of 3 x's you can take out, because we're looking for groups of 3 of a kind. So you would say, okay, well, that goes into it 1 full time, right? So that means we at least have a group of x's that we can bring out. Well, how many x's would still be left in your radical? Well, that would be 2 out of 5 still left in there. So this means we need that, this whole fractional exponent right there tells us that we have a radical that we need to deal with. So x to the 1st is going to be outside of our radical. We know that. We've already taken that and accounted for that. And then what's going to be left is this should be a 3 instead of a, and this should be, yes, and that should be a 2/3. So then we have a cube root of x squared. And then we are finished with this worksheet. Please come see me if you have any questions. Sorry about losing the worksheet. I don't know where it went. And if you have any questions, come see me and we can talk. Thanks so much for watching. Bye.